Hey everyone! Thank you so much for watching this video on achieving structured outputs with DSPy. There are so many different angles to this topic of structuring outputs of large language models. I've had so much fun researching this topic and I can't wait to share with you what I've learned. Structuring outputs with large language models is super important because large language models are stochastic models, which means that they won't consistently follow instructions that you give it. So if you tell a large language model, please format your output as a comma-separated list of values, sometimes it will give you a numbered list or say letter ordering, Roman numerals, or generally just not adhere to the list structuring at all. And we need a way to force it to output these comma-separated list of values, because the next step of our LLM program might be taking this string and then splitting it on the comma and then parsing each element of the new list. There are all sorts of examples like this. Say that you're using an LLM as your metric, your rating in a DSPy program, and you need it to output a float value. Well, sometimes a large language model will instead respond with, "Sure, I can help you with that," and then give you the rating, and you can't just cast that into a float and plug it into your metrics. So there are all sorts of different ways of looking at how to solve this structuring outputs problem with large language models. We're going to start off with DSPy's typed predictors, a super exciting new development that is really similar to, say, works on using Pydantic BaseModels and these JSON templates to format these kind of structured outputs. And there's all sorts of interesting background with this, from the function calling models from, say, OpenAI and AnyScale, Cohere. Most of the LLM providers offer this. And there's been this really interesting development from function calling to JSON mode, and the amazing path that the Instructor library has paved in showing us what we can do with this kind of syntax. And we'll explore the example gallery in Instructor in this video to take a look at all these different things you can do. So for example, you might want the LLM to output a list of users where each user has a string valued name, an integer valued age, and then another key value of properties. These are the kinds of things that you can achieve with this JSON model. The second solution we're going to look at is DSPy Assertions. DSPy Assertions is one of the most exciting things in DSPy, even complete with a paper looking around the theory and just thinking about this kind of problem of guardrails, inference time backtracking, and we're going to look into what the DSPy assertion syntax looks like and how it looks in Python, where you pass in this function and then you have this retry prompt if it fails, the difference between assertions and suggestions for whether you want to crash the program if it fails, or if you want to keep going, despite it with say one retry or something like that. The third solution we're going to look at is custom guardrails with the DSPy programming model. Because the DSPy programming model just offers us unlimited flexibility with what we want to build with LLM systems, we can easily just kind of define our own custom guardrail or output checking prompt, and then our own custom retry logic, and we can maybe compile this. And there are a lot of interesting questions there around what do you compile, the instructions for the original, the original thing that outputted the comma-separated list, the guardrails, or the retry mechanism. So we're going to explore all these things in this video: typed predictors, DSPy assertions, and custom guardrails with the DSPy programming model. Thank you so much for watching. Let's dive in. We'll start off with a little bit of background on function calling in JSON mode before diving into a hands-on example with DSPy's typed predictors. So OpenAI had released function calling amidst other API updates, and function calling was, as the name suggests, targeted at using functions and equipping large language models with functions. So in the original blog post, OpenAI gives you the example of having an input, "What's the weather like in Boston right now?" And so because OpenAI doesn't have this, the language models, GPT-4, they don't have this kind of information in their parameters to know exactly what the weather is like in Boston at this particular time. So you would instead equip them with functions where they can call something like a weather service to get the function. Now the key thing here that has kind of led us into JSON mode is that in order to use functions, they unveiled this JSON style syntax of having the name of the functions as well as giving an indication of the types of the different arguments. So say you have this argument of what city as a string, so Boston in this example, as well as the string of the unit that you want the weather returned in, whether that be Celsius or Fahrenheit. So we had this function calling from OpenAI, and you can see the documentation around function calling and what that's become, how it's integrated with products like the Assistance API. So we also had an open source version of the function calling, the Berkeley Gorilla models, and then somewhere along this line, I'm not exactly sure what the development was here, but then people started realizing that the same way that it can call functions as JSONs, it can also structure its outputs as JSONs. Personally, I suspect this is because these providers have been training their models to follow the JSON syntax for the sake of function calling, and then people realized that you could repurpose that to also output JSONs. So Instructor has been the industry leader for doing this, still is. I'm not trying to, downplay what they've done. You can also do this with DSPy, but Instructor also has these amazing things like the example gallery and generally all their content. I really enjoy keeping up with this library. So next up, we also had things like JSON mode from OpenAI. So if you are a large language model provider and you are decoding from the large language model, so large language models, they have a probability distribution over all of the next tokens, and generally you do sampling strategies like greedy decoding, where you just take the highest probability next token, or say you have a beam search through the the possibilities, and you have like this tree aggregation of the probabilities. Or you can just explicitly force it to only output open curly bracket or this particular key where that's what's needed. So JSON mode has also been a huge evangelist in this kind of JSON output structuring kind of thinking. So let's kick things off by diving into the Instructor examples. As mentioned, I think Instructor is just amazing, and it's definitely something that I think you have to mention if you're covering this topic of structured outputs with JSONs. So as you see in this repo, this will be linked in the description of the video, Instructor/examples. There are all these different examples of what we can do with these JSON Pydantic BaseModels. So let's dive into one. So we'll start off with the, so we'll do the auto ticketer. Okay, so auto ticketer, in this case, what we're doing is the following is a transcript of a meeting between a manager and their team. The manager is assigning tasks to their team members and creating action items for them to complete, and then create the action items for the following transcript data. And so you have this example where Alice says, "Hey team, we have several critical tasks we need." Bob says, "Got it, Alice." Okay, so now back to the thing we're talking about. Okay, so we have these base models, which is how we're going to be structuring the JSON. So we have the action items, which is a list of tickets. In each ticket, we then have an ID, which is an int, a unique identifier for the ticket. Then we have a name, which is the title of the task, description of the task, the priority. Okay, so now priority takes us to a priority enum. So the priority enum is saying that the priority can only be one of these three values: high, medium, or low. It can't be something like this task is of moderate priority. Like the language models will format their outputs this way. So you define these enums to structure it. And this is super useful for, say, you're using language models for classification tasks and all this kind of stuff. So then we have the assignees, and then we have subtasks. And so subtask is a list of subtasks where then each subtask has an ID int and a name string. And then again, we have dependencies and dependencies. That's a big one we could dive into. There's this really awesome paper from Berkeley that also is called the LLM compiler. It's a different kind of perspective. It's kind of similar to the UNC lab with Professor Bonsall has a paper like this as well, but it's about kind of like planning, and when you come up with a plan and then you need to resolve the dependencies, the ordering of the task. But I'm getting a little bit distracted. So let's go back to the Instructor examples. So auto ticketer, that was a pretty intense one where you had a lot of nested objects. Chain of density sounds interesting. All right, so in this case we have, okay, so write a summary about the article that is long yet highly non-specific. Use overly verbose language and filters to reach 80 words. Okay, so this is the initial prompt, and then again we have our object where we have the rewritten summary, we have the summary string, absent, there's a list of entities found absent from the new summary, missing a list of 1 to 3 informative entities, and then we have this initial summary. Okay, so hopefully you get the idea that with these examples, you can say, you can just kind of get a look at these different models and get a sense of what this means to define some kind of model of a structured output. And just, how inspiring is this? You have all these different examples of what this might look like. A CRM, again, another enum where you have personal, business, work contact, CRM search. So it's just an amazing resource for understanding what people are doing. Okay, let's dive into typed predictors. So as always, the notebooks in this video series can be found on Weaviate/recipes. And this new notebook is number 4, structured outputs with DSPy. Okay, so really quickly setting up DSPy, zooming in a bit so you can see it better. Sorry, let me zoom out a bit. Okay, so something I've started doing that I like a lot is having some kind of dictionary of LLMs and looping through them to get, an output from each of the LLMs to kind of get a sense of this whole. For me, the biggest thing about DSPy is understanding this multi-model systems where we have GPT-4 working with Command R and Mistral 7B, because you always have this like quirks in the performance. Like Command R is really great at RAG, and then say Cloud Opus is supposed to be really good at prompting other LLMs. As funny of a specific skill as that is, but we're probably going to see all these sort of idiosyncrasies around the strengths of certain models. And then of course you always will have this cost inference sort of trade-off. So diving right in, I also quickly, just to sanity check this, like to just quickly test the inference of one of the LLMs to make sure it's connected. I have the URM and Weaviate. So Weaviate is my private index in my vector database. URM is my web search, and I found kind of having this combination of information that I curate, which is easier for retrieval and highly targeted retrieval, as well as that web search for concepts that might be outside of the private index. I think that's just a super powerful thing. Okay, so next up, Arize Phoenix. Phoenix is amazing for just catching all the calls to the language model you're making. I maybe give a quick look at this. We're going to look at this later in the video, but you can, every single call you make to a language model is logged in Phoenix, and that's really great for assertions when you want to take a look, it's generally super useful anytime you're doing a ton of processing with DSPy. The compilers like Copro or Mipro are probably the best example of this, because it's just like running and it's making a ton of calls and you're curious what's happening. So this kind of Phoenix logging, I always am setting this up now when I'm working with DSPy. So here's just some more stuff around how you add the telemetry with Phoenix and that kind of thing. Okay, so in this example, we're going to be looking at that comma-separated list problem. So we have the initial signature. Your task is to write a Weaviate blog post that will help answer the given question. This is like, please use the context to help write an outline, and then the outline has this extra description, a list of topics the blog will cover. Important, this must follow a comma-separated list. So that's kind of one history of this, is doing this kind of gesturing, like the famous please output JSON or I'll be fired and all this kind of stuff. So this is just a helper function for formatting the outputs from the retrieval models. I've personally started to, I configure the retrieval model with the Weaviate RM, but I like to just use it explicitly, because say I have multiple indexes, say I have Weaviate blogs, but then I also have, say, the documentation or the code base, and I wanted to kind of stop using this DSPy.retrieve and instead just kind of use the retrieval models this way, because it gives you this, but it's good to have a default built in for some cases, and especially if you want to just quickly see the retrieval. But I like having these multiple retrieval models for the different indexes for different things I'm doing. Okay, so here's the first thing that we're going to look at. Okay, so here's the blog to outline, plugging it into a program where we plug in the signature, and then we give in the retrieval models, and then in the forward pass, we pass the question into the Weaviate retrieval model as well as the U API, and then we format the context, and then we pass it into our question to blog outline signature as defined here. So let's take a look at what each of these 4 different language models output. GPT-4, expensive, super capable model, follows it perfectly. Introduction to cross encoders, definition and working mechanism of cross encoders. It's following this comma-separated list thing perfectly. Okay, so next up, GPT Turbo does not follow the comma-separated list. Instead, we get a numbered list, 1, 2, 3, 4, and so on. So if our program then had to, dot split comma on this output, we would be in trouble. So then we have Command R. So Command R also has instead taken the syntax of using these hashtags. And then finally, Mistral 7b, in this case hosted with Olama, it has a really funny thing where it's using this Roman numeral, which is actually quite structured. But then there's this new problem that we'll look at later where there is a comma here. So it's tricky to just have one function that tries to parse it on commas, and because this actually, you can parse this on commas, but it's treating this entire thing like it's one topic. So that's another topic with this structured output with LLM kind of thing. Okay, so now let's cover DSPy type predictors, our first solution to this problem. So from DSPy.functional, we import typed predictor, we import Pydantic, and from typing we have our list. So instead of just having it output, a string where, remember in the original signature, we just say blog outline equals DSPy.output field, a list of topics that the blog will cover. Now instead we give it the type that we've defined here. So we have topics, which is a list of topics, and each topic has the topic and then topic description. Maybe title would have been better. But now we have our typed question to blog outline. Your task is to write a Weaviate blog post that will help answer the question. Again, so the same kind of initial prompt and the same description of the fields, but now we add this string for the question, string for the blog context, string for the web context, topics for the blog outline. Okay, so now we are going to be plugging this in by same kind of program, just instead of like DSPy.chainOfThought or DSPy.predict, we have functional.typedPredictor, and then we pass in our typed question to blog outline. And now again, let's take a look at how the 4 different LLMs perform with this. So starting off with GPT-4, no problem at all. Topic equals introduction to cross-encoders, topic description and overview of what cross-encoders are and their significance in the field of NLP. So you see how with this kind of syntax, you can easily get multiple outputs for one kind of call to the LLM. And that's a big part of the appeal of all this, is we get the list of topics as well as their descriptions, and it's formatted in this way where we can just loop through the, these topic objects and just have, like 4 topic and topics, and then topic.topic, topic.topic description, that kind of thing. So then we also see this works great for GPT Turbo as well as Command R. But unfortunately, it doesn't work for our Mistral 7B. And let's take a look at what happens when it doesn't work. So when it doesn't work, it is trying to retry it. So the type predictors will try to retry it, but then they'll have some threshold on, I think it's set to 3, and this is like a default in the DSPy code base. I'm not exactly sure if that's correct, but it has too many retries, crash the program. And that's going to set us up perfectly for DSPy assertions and understanding the difference between assertions and suggestions. But really quickly, you can see the different retries by looking into Phoenix, and I did log this entire notebook in Phoenix, so I might have to backtrack a little bit. Or let me just see, typed blog to outline. Okay, so type blog to outline. Okay, so here we see we have the 423 seconds latency, and there's another thing that Phoenix is helping a ton with, is you can easily see where the retries fail because it will have this outlier in latency. Okay, so we can see that it, it tries the predictor forward. So this is maybe the best view. So first, here you can see how type predictors are going to take that the Pydantic model that you gave it and format it into this kind of prompt for how it's supposed to output. So GPT-4, GPT Turbo, and Cohere's Command R, they had no problem with this this format, and this is probably similar to how they see it in function calling. As a part of, say, the Command R latest announcement was they also have said, we've increased our support for function calling, and as I mentioned earlier, I think that's highly correlated with how well they can then output structured JSON. But anyway, so the Mistral model takes that input, and then these are the web contexts that it's retrieving, and then it gives you this outline of, again, this kind of thing. So it's not following the type model at all. It's doing that same kind of list of introduction and so on. Really quickly, before moving on to DSPy assertions, I want to highlight this example created by Thomas Ale, the genius behind type predictors in DSPy to begin with. So in this example, what we're looking at is Python code. So this is pretty future looking. This is like Devin, Open Devin. I think all that stuff is just so exciting, where language models directly output executable Python code. And definitely be careful with that one a little bit. But so we have this case where you have the different strings that are supposed to be Python code. And in this case, the Pydantic field validator is taking the code string, and then it's checking if you can compile the code by using the Python REPL. So here's just another super cool example of what you can do with type predictors. And we're also going to look at type predictors again later in the video with the typed optimizers, which is pretty interesting. So coming back to the notebook, next up, let's look at DSPy assertions. So DSPy assertions have backtracking to allow pipelines to self-correct at inference time by retrying failed modules with refined prompts. So let's dive into what that means. So we start off with the function that we're going to be using to check one of the outputs of our DSPy modules. In this case, is comma separated list, where it's going to try to split the list on the comma and then see if it's able to do that or not. And if it fails, it's going to say output must be a comma separated list of topics. Please remove any numerical listing as well. So this is like something else that I've added to the prompt as I've been playing with this, and I see that this is like the most common error mode with why it fails to output the comma separated list of blog outline topics. So the way that we interface this with our DSPy program is first we, same way of defining the different modules, the different components that we're going to be using, like our question to blog outline module and our retrieval models. But now after we run the inference of the self-to-question.blog outline, we're now going to take that output and pass it in as input to the is comma separated list function that again we defined up here. So we're going to pass in this output, and then if it fails, we're going to give it the failed assertion message. And so this is the failed assertion message. And in a second, we'll see what that looks like in our Phoenix traces for how it's going to format the prompt. And so then if it doesn't fail, or even if it retries it, it will still put it in that same namespace of question to blog outline outputs dot blog outline to return. So again, let's take a look at what each of our different LLM, oh sorry, there's actually one more part of this. So now what we're gonna do is we're gonna wrap our program in the assert transform module wrapper, where we pass in the program of the blog to outline with assertions that we've defined here. And we pass in functools, backtrack handler, max backtracks 1. So this is, we're saying how many times it should retry the prompt. Okay, so now let's dive into how each of the language models do with this. Okay, so again, with GPT-4, we don't even need to bother, just right out of the gate, it understands this comma separated list idea. All right, so next up with GPT Turbo, it fails the original one, then we get this output must be a comma separated list of topics, and then it properly formats the output. Again, with Command R, it fails and then succeeds. But unfortunately with Mistral, with Mistral, again, we have this problem. Because of this comma right here, it is actually a comma separated list. So with this one, we need a little more thinking, which we'll see later with the custom guardrails. So now let's dive a little more into the Phoenix trace just to get a sense of what this reformatted prompt ends up looking like when the suggestion fails. So what happens, sorry, ran a bit of this. Okay, so, this is the type blocked outline. Okay, with assertions. Okay, so let's look for one with some latency. Okay, so here we are. It's just latency because of the local OLAMA. Okay, so maybe, okay, let's take a look at this one. Nope, OLAMA, sorry, that was probably the same one. Not OLAMA. Okay, sorry about that. Okay, so here's what we're looking at. So we have the original prompt where we're passing in this, your task is to write a blog post. Please to evaluate the structure of the blog post. Okay, so here we are in our Phoenix trace to understand how we're going to be reformatting the prompt with the error message. So we start off with Command R and the prompt of please outline the blog outline topics, and instead we get the hashtags kind of output. So now when we're retrying the prompt, we're going to add this additional message. So we have our output in the original prompt, and we had the past blog outline, and now we add the instructions. Output must be a comma separated list of topics. I think it might have truncated also the other part of the error message, but I'll have to look into that later. But okay, so then it retries the blog outline. So hopefully you just see this part of how it's going to be retrying. So finally, let's take a look at custom guardrails with the DSPy programming model. One of my favorite things about DSPy is how flexible it is. We can easily add additional signatures and modules and have this programming model where we're programming these language model systems, and we have unlimited flexibility with what we might want to add to the processing. So in this case, we're going to define our own topic guardrail signature. We have please assess whether this generated topic list is properly formatted as a comma separated list. And then we have the output fields properly formatted and reason for properly formatted decision. So already maybe we're starting to see how there could be some overlap between typed predictors as well as custom guardrails. And in a second, we'll also see the overlap with assertions as well. So these three techniques, they're not like competing with each other. You can use them all together. And these are just a few different perspectives for understanding this big class of algorithms around structured output parsing with LLMs. So anyway, so staying on this. So then we also have our retry topic. We start off with the prompt, given the original output and the reason for its failure, because we have this reasoning as well. Please correct it. Please also remove any extra text before the topics. And so this is just something that I found as I was starting to, try to make this work better. So now the way that we do this is in our forward pass, we're going to be, or first in our program, we're going to have blog to outline with custom guardrails. And we add these two additional modules, topic guardrails and retry topic. So then in the forward pass, we generate our blog outline and, say we have a counter. I don't know if this is the best way to write these loops. I was a little bit tired when I was writing this, but anyway, so now while true, and again, we can have these multi-model systems. So this is another kind of part of why I would advocate for doing custom guardrails. I like all these solutions. They're all great in their own way, but one way if you're doing it like this is you have a little more control over the multi-model systems. So say I always want GPT-4 or the most capable model to be doing that check on the structured output. And that also kind of opens this up where there could be more than one kind of way of looking at guardrails. I think when, guardrails, the kind of category originally was being popularized, people were thinking of this as avoiding harmful content. Like if the LLM would say something crazy, you'd have some kind of guardrail to say, whoa, we're not going to send that. Let's try that again. And so that's that kind of esoteric guardrail that, a type validator can't check. It can check if it's a string or if it's a particular Pydantic model, but it can't check like if it's doing a summary chain and all of a sudden it just completely changed the topic of the summary. So this is kind of the flexibility that you get with assertions, as well as sort of like a custom guardrail, which is really just like a way to take the assertion and have maybe a little more control over it if you need that, which you might not need that. So now we pass it into our guardrails. So then we take our guardrails outputs, and I'm just logging this for when we're going to print it, going through each of the models again. And then if the guardrails output is true, then exit the loop. We've got our blog outline. If not, then we're going to take out the reason for failure, and we're going to call the retry topic by passing in the original blog outline as well as the reason for failure. And then we're going to overwrite it into the new blog outline as we continue looping and evaluating whether it passed the guardrails. So then we have this counter where, if we've tried more than 3 times and, all right, that's as many times they're going to retry, and we're going to exit and just return the break. So again, hopefully you see this kind of difference between DSPy assertions and DSPy suggestions, where with suggestions is like this kind of approach. You exceed the retry limit, so okay, let's just return what we've got. Whereas assertions, you would say, no, let's crash the program. It does not return anything. So that's kind of an important detail with how you're doing this as well. Okay, so now let's take a look at how our language models do with this. So with GPT-4, again, it does it perfectly right out of the gate, properly formatted, true, and then the reasoning if interested. But you see, just right out of the gate, it understands how to write this comma-separated list for the topic, how does HNSW work. So then with GPT Turbo, false, the provided topic list is not properly formatted as a comma-separated list. It uses a hyphen to separate the items instead of commas. So then it retries it, and now we have this output on the retry. Again, false, saying that there's no space after each comma. So we see already it's not super perfect, but yeah. So we keep retrying it, and eventually we get this. So it's failed by its own admission, but it has produced a good blog outline as a result. And you can imagine combining this kind of thing with the type predictors as well. So there's definitely a lot of overlap with how you want to do this. So again, with Command R, you see false, the topic list is not properly formatted because of this. Then we retry it again, and then we retry it again, and at the end we end up with this, a comma-separated list of topics. So then with Mistral 7b, similarly, it also is able to be corrected this way. And so hopefully this shows you this example with Mistral 7b with the original output. When we have this kind of output, it's hard to just kind of have a validator on this, because we can indeed parse this with the comma separated list because of this, but we need the LLM to sort of serve as the guardrails to look at the input and say, oh wait, this isn't what we're after. Or you could probably also do things with like regular expressions to check for this kind of thing, that would be maybe more of a headache as the language model inference is getting cheaper and more effective. So maybe an interesting thing to think about. Thank you so much for watching this video explaining how to achieve structured outputs with DSPy, looking at 3 different ways of doing this with typed predictors, DSPy assertions, and custom guardrails with the DSPy programming model. I'm so excited to keep up with this topic. I think there's a lot of overlap and intersection between these 3 different kind of ideas I've outlined as well, like using typed predictors within the custom guardrail function, or putting the custom guardrail function then into a DSPy assertion where you say compile the guardrail function. All sorts of exciting things as we're going to continue to follow along with the development of structured output parsing. All the notebooks in this video series on DSPy can be found on Weaviate recipes. If you go to integrations and then DSPy, and then here are the notebooks from this series. There's all sorts of other things in the Weaviate recipes repository that I highly recommend you check out. And if you're interested, if you have a particular question that you'd like our advice on, maybe you can go to issues and then say this was a great example from David Winter, who was building a chatbot and wanted to learn how to build a classifier with DSPy and Weaviate. And so, if you have a question like this, we'd be more than happy to answer it. Just open an issue on recipes. Also, you can connect with me if you're interested on X at cshorten30. Thank you so much for watching.